Over 100 students participated in DSU's Engineering Design Day events, showing off a culmination of their engineering skills and knowledge up to this point. The freshmen created miniatronic golf courses for the public to try out using moving parts, sounds, and lights.
We're able to make creative ways to make certain monsters or ships, such as this sea monster right here. It has some moving arms, and once the ball goes through, its eyes flash. And along through the boats, this one with the white sails is able to recognize the color of the ball and to make different sounds according to the ball. And these other ships, once you pass through, will light up, kind of like ships fighting. And you can't see it from this angle, but there's a little gator head just a little bit further, and it chomps your ball if you're too slow. And once you get to the prize, to the treasure, you're able to see the parrot move and kind of make fun of you.
And the fact that they engineered all these little parts moving and little things talking and lights lighting up, I think is just awesome. You know, what a treat it was to come and see what all the kids have done here.
By using practical skills and teamwork, these students put their talents to the ultimate test.
So it's always great to judge this golf course event. I've done it twice, and the students are always creative.
The sophomores showcased their talents driving through rugged terrain using critical data in their robot recon.
Now the robot recon, it looks like just robots driving around, right? But it's more than that. So the students go deep into statistics so they can learn how to robustly take temperature data and flow data and weight measurements, right? And so it's a lot more involved than it looks.
And for the first time ever, the more advanced students took to the water in their first annual Turbo Regatta after designing mechanical pedal boats without the pedals.
And so they're learning to design, gears and drive shaft systems. And this particular event, Turbo Regatta, presents some difficult challenges, such as designing that drive shaft, as well as, making it waterproof and dealing with high power applications.
The students were quick to learn how to debug their systems and make them work on the fly. However, some didn't have as much luck. But you're not disappointed, you got to try it out, right?
No. we were happy with it. We were happy it just turned on.
It took a lot of hours and hard work to design and make their applications run.
Well, so this gear got a little bit of wear on the worm. So what we're doing is we're kind of shifting it so it'll wear on a different part of the gear, so that there's less of a chance of anything going wrong. Granted, we haven't had anything happen yet, but we're just trying to prevent it.
Each boat had to carry identical weight of 400 pounds. While some boats made it through the competition, others had problems once they got into the water and got wet.
Like set screws breaking, or like propellers sort of shearing off, right? These are all like real world problems that they would have to solve and make very robust.
In the end, the greats were the winners, as they were able to complete the full course.
So we are the greats. We ended up winning probably because we were one of the only groups that actually had dual propellers. Also, we did a little testing and we figured out that if we ran it to its full capability, like a lot of the other teams were trying to do, it would wear out the gears faster, so we decided to dial back.
So these particular gears are made out of what's called PLA. It's a type of 3D printing filament, which is how we made it, was by 3D printing. PLA is very susceptible to absorbing moisture from its surroundings. Even like moisture in the air, it'll absorb it and it'll become brittle. So since it's in the water, obviously it's going to get a lot of water in there, and it makes it brittle over time. It was one of the design constraints was we weren't allowed to buy metal gears, so we just decided to do PLA and hope for the best, and apparently it's been working so far. So
we kind of did the best we could, and it ended up working out okay.
I did not think we were going to win at all. I thought we would probably break something before we got to the end. Probably the worm gear, but hey, I guess, life's full of surprises.
I'm really happy with the way it worked. I'm sure you've heard it 2 other times, but we didn't think it was going to work at all.
From Dixie State University, Melissa Anderson, Community Education News.